morning, children. Let's continue with exercise 6.1, question number 4. In the figure, it is given that x plus y is equal to w plus z. That means x and y represents a pair of angles, w and z represents another pair of angles, and it is given that x plus y is equal to w plus z, and prove that angle AOB is a straight line. What is to prove is AOB is a straight line. How do you prove that AOB is a straight line is, you have to prove that angle AOB is 180 degree. Whenever a straight angle occurs, we can say that it represents a straight line. If you start with the central angle proof, angle at the center is always 360 degree. That is x plus y plus z plus w is equal to 360 degree. Angle at the center is 360 degree. X plus y and w plus z are equal. Let us replace z plus w as x plus y by the given condition. X plus y is equal to 360. It's already from the given condition. X plus x is giving you 2x. Y plus y is giving you 2y, or 2 into x plus y is equal to 360, or x plus y is equal to 180. Therefore, angle AOB is equal to 180 degree, or AOB is a straight line. Question number 5. In the figure, POQ is a straight line. Ray OR is perpendicular to line PQ. OS is another ray between rays OP and OR. Prove that angle ROS is equal to half angle QOS minus POS. In the figure, POQ represents a straight line. OR is perpendicular to PQ. What is to prove is angle ROS is equal to half angle QOS minus angle POS. Since the proof starts as, since OR perpendicular to PQ, angle POR is equal to angle ROQ is equal to 90 degree, or POR is the total of angle POS plus angle SOR is equal to angle QOR is 90 degree. Equation number 1, or angle ROS has to be separated in the left hand side, which shows that angle ROS is equal to 90 minus angle POS. Mark it as equation number 1. Now, adding angle ROS to both sides, we are getting angle ROS plus angle ROS is equal to 90 minus angle POS plus angle ROS. That is 2 times angle ROS is equal to 90 plus ROS minus angle POS. 90 plus ROS is giving you QOS minus angle POS, or angle ROS is equal to half angle QOS minus POS. That is the proof. Question number 5 is this one. Question number 6, you can try on your own by reading the question from the textbook. The next topic in the lesson is the theorems and axioms based on parallel lines. Before that, let us derive a few pair of angles which should be known to you. when two lines are cut by another line or when two lines are intersected by a transversal. That means if AB and CD represents any two lines, let AB and CD represent two lines. They may be also called as L and M. If you avoid the letters as AB, they can also be represented as line L and line M. Then, if another line T intersect the given lines at the point C and at the point E and F, you can see here there are angles formed at each of these points and they represent certain pairs of angles. What are the pairs of angles formed here are angle 1 and angle 5, the pair, angle 4, angle 8, angle 2, angle 6, and angle 3, angle 7. The pair of angles 1, 5, 4, 8, 2, 6, 3, 7. If you see the peculiarity, the pair is above the line, this pair is below the lines. Similarly, on the other side, the pair of angles above the line and the pair of angles below the lines, they are called corresponding angles. That means, if two lines are intersected by a transversal, there are four pairs of corresponding angles. And now again, if you take the angles in the combination, what I am going to take as 3 and 5, the next combination of 4 and 6, they are on either side of the transversal and at the same time they lies to the interior of these lines. They are called as alternate interior angles. Alternate interior angles. There are two pairs of alternate interior angles and then one more pair of angles represented as 3 and 6 as one pair and 4 and 5 as another pair. They are named as co-interior angles. That means they lies on the same side of the transversal. So they are called as co-interior angles. That is, there are two pairs of co-interior angles. Thus, in general, if two lines are cut by another line called a transversal, there are four pairs of corresponding angles. There are two pairs of alternate interior angles and there are two pairs of co-interior angles as mentioned in the figure. Now, what will happen to these pairs of angles if the lines are parallel? That is the topic under the consideration of class 9. The angles, how are they related when the lines are parallel? The first condition of if two lines are parallel, the corresponding angles are equal will be considered as an axiom. That means if two lines are intersected by a transversal, then pairs of corresponding angles are equal. That is, the first axiom which doesn't require a proof. So the topic is parallel lines and transversal. The first axiom says that if two parallel lines are intersected by a transversal, then pairs of corresponding angles are equal. From the figure, what can we say is, if AB parallel to CD, then the pairs 1 and 2, angle 1 and angle 2 are equal, angle 5 and angle 6 are equal, angle 3 and angle 4 are equal, angle 7 and angle 8 are equal. That is the meaning of this axiom. And now what will be the converse of this axiom is, the converse statement is, if two lines are intersected by a transversal in such a way that a pair of corresponding angles are equal, then the lines are parallel. It is not compulsory that all pairs of corresponding angles should be equal. If at least one pair of corresponding angles are equal, we can say that the lines are parallel. So, the corresponding angles axiom and converse of it can be used as the help factors for proving the next two conditions as theorems. Theorem 1. In this topic, if two parallel lines are intersected by a transversal, then each pair of alternate interior angles are equal. So by reading the statement, we have to draw the figure. If two parallel lines, immediately let AB and CD represents two parallel lines and let T represents the transversal. Each pair of alternate interior angles. Let's mark it as 1, 2 as the first pair, 3 and 4 as the second pair. Now, so the given condition is given AB parallel to CD, and what is AB parallel to CD? To form alternate interior angles, or you can write to form two pairs of alternate interior angles, angle 1 comma angle 2, angle 3 and angle 4. And what is to prove is angle 1 and angle 2 are equal, angle 3 and angle 4 are equal. Now, as I told you, we can apply corresponding angles as an axiom. So, mark angle 5 as one of the corresponding angle to angle 2. The proof starts from there. Proof: angle 5 is equal to angle 2 since AB parallel to CD, angle 5 is equal to angle 2 corresponding angles. Corresponding angles are always equal. But what is the relation between 5 and angle 1? They are a pair of vertically opposite angles. But angle 5 is equal to angle 1 vertically opposite angles. Mark it as equation 1 and mark it as equation 2. From 1 and 2, angle 5 is equal to angle 2 Angle 5 is equal to angle 1. Therefore, angle 1 and angle 2 are equal. That is, the first pair of alternate interior angles are equal. Similarly, angle 3 is equal to angle 4. You need not prove, but it is understood. How do you prove the converse of this theorem? It is given that if two lines are intersected by a transversal in such a way that at least one pair of alternate interior angles are equal, then the lines are parallel. So, the given condition is two lines AB and CD is cut by a transversal T and they are forming angles 1 and 2 as alternate. At the same time, the angles are equal. 3 and 4 is another pair which is equal. What is to prove is AB is parallel to CD. So, the given condition is two lines AB and CD intersected by a transversal forming two pairs of alternate interior angles, angle 1, angle 2 and angle 3 and angle 4, and what is the extra condition? Such that angle 1 and angle 2 are equal, angle 3 and angle 4 are also equal. What is to prove is AB is parallel to CD. For proving converse, we will be using the converse of corresponding angles axiom. The vertically opposite angles is always a proof we have done previously. The same procedure, the proof starts as angle 1 is equal to angle 5 vertically opposite angles. But what is angle 1 and angle 2? They are equal, but angle 1 is equal to angle 2. It is already given as equal. From that, you are getting angle 5 and angle 2 are equal. In the figure, 5 and 2 are one pair of corresponding angles and you proved them as equal, which shows that the lines are parallel by the converse of corresponding angles axiom. But how do you present the answer? These are a pair of corresponding angles. Therefore, AB parallel to CD, and in bracket you can write by converse of corresponding angles axiom. Angles axiom. In a similar way, we will be proving the third property also, as co-interior angles are supplementary and its converse, that is, you are learning it as a theorem. The next theorem is on the co-interior angles. When two parallel lines are intersected by a transversal, then each pair of co-interior angles are supplementary. So this is the theorem. After the statement, you are drawing the figure. Let AB and CD represents two parallel lines and let T be a transversal such that a pair of co-interior angles 1, 2, 3, 4 are formed. So given AB parallel to CD, transversal T intersects AB and CD, forming co-interior angles. The first pair 1 and 2 and the second pair 3 and 4. So according to the theorem, the co-interior angles are supplementary. That means their total is 180 degree. So what is to prove is angle 1 plus angle 2 is equal to 180 and angle 3 plus angle 4 is also 180 degree. Now, when you need a total of 180 degree on the right hand side, the axiom you can use is the linear pair axiom. Any one of the side you can apply linear pair axiom. Let's take angle 5. Now, here give a letter as G. Ray GA stands on transversal T. The proof as ray GA stands on transversal T. Therefore, linear pair axiom says that angle 1 plus angle 5. Therefore, angle 1 plus angle 5 is equal to 180 degree by linear pair axiom. Again, 5 and 2 are equal by corresponding angles axiom. But angle 5 is equal to angle 2. The reason is since AB parallel CD, corresponding angles, that is also an axiom. If you replace the value of 5 as 2 in equation number 1, you will get the answer as 1 plus 2 is equal to 180. Therefore, substituting angle 5 is equal to angle 2 in equation 1. Angle 1 plus angle 2 is equal to 180 degree. That is, the co-interior angles sum is 180 or the co-interior angles are supplementary. You can just write similarly, angle 3 plus angle 4 is also 180 degree, the second pair of co-interior angles. The converse of the previous theorem, if two lines are intersected by a transversal in such a way that at least one pair of co-interior angles are supplementary, then the lines are parallel. The same, given AB and CD are two lines and transversal T intersect AB and CD, forming one pair of co-interior angles 1 and 2 such that 1 plus 2 is equal to 180. Given AB and CD are two lines, transversal T intersects AB and CD, forming co-interior angles 1 and 2 such that, what is the condition? Angle 1 plus angle 2 is equal to 180 degree, and what is to prove is the lines are parallel. The same as the theorem, you will take the help of linear pair axiom. Same way, you can give the letter here, proof. Ray GA stands on transversal T. Therefore, 1 plus 3 is equal to 180 degree, equation number 1. That is linear pair. So, what is the given condition? Given condition is 1 plus 2 is equal to 180. But angle 1 plus angle 2 is equal to 180, equation number 2. That is a given statement. So, what will you do with the equations 1 and 2 is equating 1 and 2. Angle 1 plus angle 3 is equal to angle 1 plus angle 2, equal angles from both the sides, that is 3 and 2 are equal. What type of angles are they? Angle 3 is equal to angle 2, but these are a pair of corresponding angles for AB and CD. Therefore, AB parallel to CD by converse of corresponding angles axiom. So once you understand the proof and you know that corresponding angles axiom can be used, you can either take the help of vertically opposite angle or linear pair axiom to prove the remaining two theorems. There is one more property regarding parallel lines in this topic, that is, if two lines L and M are parallel to another line N, that is, if L parallel to N and M parallel to N, then L parallel to M also. That is, if you have a line L parallel to N, M also parallel to N, we can very well prove that L and M are parallel. How can you prove it? So, given L parallel to N, M parallel to N, and what is to prove is L is parallel to M. We will write the statement later on because it can be used as a property as well. Now, since L and N are parallel, we can take one pair of corresponding angles. Proof: since L parallel to N, angle 1 is equal to angle 2, corresponding angles. Similarly, M is also parallel to N. Since M parallel to N, we have 3 also equal to 2, another pair of corresponding angles. From 1 and 2, angle 1 and 2 are equal, angle 3 and 2 are equal, shows that angle 1 and angle 3 are equal. 1 and 3 are corresponding angles for L and M, and so L is parallel to M also by the converse of corresponding angles axiom. Therefore, L parallel to M by converse of corresponding angles axiom. So, what is the important theorem or property is two lines parallel to a given line that is, we are talking about two lines means L and M. Parallel to a given line means the given line we are talking about N. That is, if L parallel to N, M parallel to N, then automatically L and M are parallel. See the statement? Two lines parallel to a given line are parallel to each other. Parallel to each other. This is a very important property which can be used in the remaining part of the lesson.